Hi everyone, I want to go over the stoichiometry quiz we had today, so that maybe you can learn from that a little bit and it'll benefit you on the exam here. I printed out here in the OneNote notebook our quiz summary of the statistics of it. You see the high score was an 80, the average score was a 40. On average took you 24.5 minutes to do the quiz. So looking at the questions, the first one you're asked to get the molar mass of sodium carbonate, Na2CO3, and you look at the periodic table and sodium is element number 11, but its mass number is basically 23. It's 22.999 whatever, but basically 23, and then the subscript non-sodium carbonate is a 2, so we have 2 of those, so 23 times 2 is 46. Carbon is only one carbon there, and its atomic weight is about 12, so 12 times 1 gives me 12, and then oxygen, atomic weight 16, and we have 3 of them, that's 48. And if we add those up, 8 and 2 is 10, and 10 plus 6 is 16, so that's a 6, and I carry my 1, and 1 and 4 and 1 and 4 adds up to 10, so 106 is the correct answer, which folks got here, most of you got. 6.02 times 10 to the 23 is obviously Avogadro's number, and then I think the other ones were basically things where I either ignored the subscripts, so like I think 23 plus 12 plus 16 is 51, and then one of them I got by adding up the atomic numbers instead of the mass numbers. So the wrong answers, there was kind of a rationale behind them. Okay, the next question was a formula response question, and it looks like everyone got this one right, so that's great. Where you see this bracket G here, that is a variable in the formula question, so it could have been any value. So let's just say that was 12.3 grams. So if we say it was 12.3 grams of my C3H8, then what I would do is multiply by 1 mole of C3H8 divided by, and then I would figure out the molar mass of C3H8. And again, I've got C3H8, carbon is 12, I've got 3 of them, that's 36. Hydrogen is 1, I've got 8 of them, that's 8, so that's 44 grams for every 1 mole of C3H8. So if I grab my calculator here, 12.3, which is again what I assumed the variable was, just to pick a number. So 12.3 divided by 44, that gives me 0.280 as my answer in this case, and that would be moles of C3H8 because the grams of C3H8 canceled out in each case. That's a sample of that. But again, it looks like most of you who took this did very well. Next question was asking how many grams are in a given number of moles, in this case of hydrochloric acid. So let's just say that we take our 0.280 moles there and use that again. So now I want to know how many grams of HCl are in 0.280 moles of HCl. And again, 0.280 is just a kind of a random number that we picked to use here. That bracket M is a variable. What I need is something that has moles of HCl on the bottom and grams of HCl on the top, and that's going to be the molar mass of HCl, which is how many grams are in 1 mole. Anytime you have grams and moles in a conversion factor like this, you always have 1. Hydrogen has a mass of 1, and we only have 1 of them. Chlorine is 35.453, so 35.5 is close enough. 35.5, add that up, you get 36.5 as your molar mass. So 36.5, so 0.280 times 36.5 gives us 10.22 grams of HCl. And again, we know it's grams of HCl because moles of HCl canceled out. So basic mole, gram, gram, mole conversions there. Question, whatever the next one is, whatever number we're up to here. So I guess this was 1 here, and then 2, and then 3. So we're getting up to question 4 here on the quiz. Ask you to look at this reaction of 2 carbon monoxides with 1 oxygen to form 2 carbon dioxides. And we're told that we have excess carbon monoxide, but you're given a number of moles of O2, and you're asked to calculate how many moles of CO2 would be made. And so whatever that is, let's just say that if M, let's say that was 0.123 moles of CO, just to pick a number. All we have to do is construct a conversion factor that's got moles of CO on the bottom, because we want to cancel that out. And keep in mind that in chemistry, CO is not the same thing as big C, little o. Big C, big O is carbon monoxide. Big C, little o is cobalt, so don't get confused about that. The thing we need on the top is we're trying to get moles of CO2, so we want moles of CO2 on the top. And where we get these numbers that go right here is we go back to our balanced equation and we look at these coefficients. So that's 2 over 2, which means it's just the same value, 0.123, except now it's moles of CO2. And again, those of you who took this seem to do pretty well on it. All right, question 5 here was one where you're now asked to put that mole-to-mole relationship in a reaction together with the gram-to-mole conversions and going in both directions. And looks like a bunch of you did well on this too. Well, actually, no, I take that back. Those are ungraded answers, so I don't know what's going on with that. I'll go take a look at the quiz and see. Let's just pick a number. Let's say that we had 20 grams. So we'll say we have 20 grams of C3H8. And we're going to figure out how many grams of CO2 we can get. And so what our path has to be is we're going to go from, I like to think of it this way, I'll write the reaction again down here. All right, so we're trying to get grams of CO2, which I'm going to write that right there. We know we have, in this case, I said 20 grams, and again, I just picked that number for problem, gave you a variable bracket G there, 20 grams of the C3H8. We can't go directly from one to the other. We have to go to moles of C3H8 and then to moles of CO2, and then we can go to grams of CO2. So there's basically a 3-step process, which I'll call them A, B, and C. So we're going to wind up with 3 conversion factors here corresponding to that A, B, and C there, the 3 steps we're going to. So the first step, we're going to convert grams of C3H8 to moles of C3H8. And we worked it out before that that's 44 grams of C3H8 in every 1 mole of C3H8. So grams of C3H8, grams of C3H8 cancel out, because that line down the middle there means divide, and grams C3H8 divided by grams C3H8 is 1. Our second step, so that would get us, we would be at this box after A. Down here we'd reach this box. Our second step is going to be to go from moles of C3H to moles of CO2. We're going to get those numbers from the equation here. And if you look at this, we're told that 1 mole of C3H8, whenever that reacts, we get 3 moles of CO2. So we pull those from our equation. We can cancel out moles of C3H8. That gets us to this box down here. And then at that point, we're going from moles of CO2 to grams of CO2. So if you do the analysis, 1 mole of CO2, carbon is 12, oxygen is 16. That gives us 44 grams of CO2 on the top. And we can cancel out moles of CO2 that way. So to get our answer, we're going to take 20 times 3 times 44, and then we're going to actually divide it by 44, so it's going to be 20 times 3. It winds up being 60 grams of CO2 would be our theoretical yield for this last question. So that's a quick overview of that quiz, and I hope that helps you do well on the exam.